our development of the atomic theory, we've got several different discoveries being made at the end of the 19th century and entering into the 20th century. We just got done talking in class about Thomson and his discovery of the electron and development of what we would consider to be the plum pudding model of the atom. At around the same time this is being done, we've got some different elements being discovered. Radium was one of these elements that was discovered and isolated. And a scientist by the name of Ernest Rutherford studied radium and the energy that it gave off, because these particles, or this atom, this element, was a radioactive material. He studied the emanations that were given off, what we now call radioactivity, and found that there were two types of radioactivity being produced by radium. He called these alpha and then beta. A third type of radioactivity was also discovered as he was conducting his experiments, and he named that radiation gamma. In the experiments that were being done, he isolated these by doing something very similar that Thomson did in identifying the charge on the electron. He simply set up two charge plates, and as the radioactivity came out of the radium, as the radioactivity passed through the plates, it separated based on their charges, with the alpha being positive and with the beta being negative. One of the things that as part of this that he discovered was that alpha had a much larger mass than what these beta particles had, approximately 8,000 times more massive. The gamma rays were neutral, so they were unaffected by these plates that were being used. One of the other things that's important to understand is that there's different energies associated with these types of radiation. Alpha particles have the least penetrating power, meaning they can't go through much material, whereas gamma rays are the most penetrating and go through quite a bit of material. The beta particles, somewhere in between.